Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are continuing with chemistry, and we are looking at the basics of the stoichiometric calculations that we can get. To begin with, here is a sum that we have. What mass of iron sulfide is formed if 6,4 grams of sulfur reacts completely with iron? Now to do the sum, to begin with, what we'll have to do is write down the equation. So the equation is Fe plus S will give you FES. And we have to make sure that the sum is balanced. So we see that in this case it is balanced. Now that we've written down the equation, the first step is done. The second step will be to write down the relevant parts. So the relevant parts to the sum that we have here is we see what mass of iron sulfide is formed. So the question is what mass of iron sulfide is formed. So we put a question mark on the unknown, and we are given 6,4 grams of sulfur. So the sulfur will be 6,4 grams. So the relevant parts have been identified. Now the third step would be for us to calculate the moles of the relevant parts. So here we see we got 6,4 grams of sulfur. So let's work out the number of moles of sulfur we actually have in doing our reaction. We got 6,4 grams, and if we look at sulfur on the periodic table, you see that it has a mass of 32, and if you work that out, 6.4 divided by 32, and that's going to give us 0,2 moles. So we see in actual fact in our case, because we are working with 6,4 grams of sulfur, we end up having 0,2 moles of sulfur reacting. Now that we have 0,2 moles of sulfur, we have to look at the ratio. And from our ratio, we see that 1 mole of sulfur with 1 mole of iron sulfide. Therefore, we can say that 0,2 mole of iron sulfide is formed. Now that we have the ratio and we know the number of moles of iron sulfide is formed, we can calculate the mass of iron sulfide. The equation we'll use is equals to M is equals to N times M. And here we can see that our number of moles of iron sulfide was 0,2, and our molar mass of iron sulfide, the mass of the iron is 56, and the sulfur is 32, and 56 plus 32 will be 88 grams per mole. So this is working on the molar mass of iron sulfide, right? And just looking at layout, if we fix it up, we can say it like that. We get 88, so the molar mass is 88. So we get 88, and 88 times 0,2 will be times 0.2, which gives us 17,6, and the answer here will be 17,6 grams. So that will be the answer for calculating the mass of iron sulfide that will be formed using the stoichiometric process as defined that we have in our sum. So just looking at it again, we see that if we wanted to work out what mass of iron sulfide is formed from 6,4 grams of sulfur, if 6,4 grams of sulfur reacts completely with iron, then what we had to do first was write down the balanced equation. In our case, it was Fe plus S gives you FES, and we were fortunate it was balanced. The second step, what we had to do was identify the relevant parts, relevant information. And in our case, we see that we had 6,4 grams of sulfur, and they wanted us to calculate the iron. Then the third step that we had to do was to work out the mole of the given. And in our case, the given part was the sulfur. So we said 6,4 number of moles is equals to actual mass over molar mass, which is 6,4 over 32, which gives us 0,2 moles. Then by looking at the ratio of moles of given and moles of unknown, we see that the ratio is 1 into 1. Work out the ratio, and then we can work out the ratio. You can work out the moles of what we have to find, the unknown part. And then once we have the moles of the unknown part, we can work out the mass of the unknown part, which we had to calculate in our sum. So we can use this 5-step process in order to figure out how to do the sum related to stoichiometry. Now, taking this a little further, I have another way in which we can do the sum, and what we can do is I'll do it in green, so you can see that it is another way of doing the sum, and sometimes it is an easier way, but we have to see what is given in the question in the exam to see if it works. Now, if you look at the sum, I'm beginning the sum again and explaining it using a different process. The question is, what mass of iron sulfide is formed from 6,4 grams of sulfur? So what we see here is this is a mass calculation. It's a mass sum. We have what mass iron plus sulfur gives us iron sulfide. And the question again says, what mass of iron sulfide is formed? So we want to know what mass of iron sulfide is formed from 6,4 grams of sulfur. 6,4 grams of sulfur. So to do the sum, because it is a mass sum, what we have to do, we have to say, according to the periodic table, what would have reacted if we had the ideal situation in terms of the periodic table. So using the periodic table, we see that 32 grams of sulfur will form, and then we work the sum out before, where this is 56 plus 32, will always form 88 grams of iron sulfide. So this is a rule. We see that 32 grams of sulfur always will form 88 grams of iron sulfide, because if we take the masses from the periodic table. But we have 6,4 grams of sulfur. Therefore, X grams of iron sulfide will be formed. Now I'll just write it a little bit different here to make it easier to do the maths. 32 forms 88. Therefore, 6,4 will form X. Now, if you have to find X, we do it by cross multiplication. We take the bottom and we take it onto the top on the other side. We take this there and we'll take this there on top. So we get 32X is equal to 88 times. We divide both sides by 32, and then we see that we get, let me just show you the cross multiplication. Then if we say, we say therefore X will be, and we get 17,6 grams. So here we have a mass calculation, and by doing it a different way, we see that we get the same answer. Here our steps was first work out our balanced equation. The second step will be to identify relevant parts. In our case, the relevant parts are 6,4 grams of sulfur will form X grams of iron sulfide. Then we use the periodic table masses. We use periodic table masses. So we see that according to the periodic table, 32 grams of sulfur will form 88 grams of iron sulfide. And then number 4, we solve for x. So that will be another way of doing the sum. And here we see that we got 17,6 grams. And in the previous sum, we see that we also got 17,6 grams. In the first process, we did the sum. By calculating the moles. And in the second sum, we worked with masses compared to with masses. So that is the basic sum relating to stoichiometric reaction referring to mass-mass calculations. Thank you very much for watching.